All right, let's do a quick review of how to find volume of solids. So when you are given a solid figure and you need to find the volume, you need to work with some formulas. So on each one of these pages is a formula sheet. If I'm looking at this solid figure, I know it is a rectangular prism. So I'm going to rock that rectangular prism formula for volume. So we'd be looking at that formula. Volume equals length times width times height. We'd substitute our length, our width, and our height into the formula. And I would get 120 cubic inches. All right. How about this one? I'm looking at this solid. I know it's a type of prism. I know that it is a triangular prism, which means that my bases are triangles. So here's one of my bases. And I looked over here, my general prism formula, volume equals area of the base times the height. So when it has that capital B, typically it means that this is the area of the base. So you have to identify the base and find the area of it. So here's my base, it's a triangle. So I need to do a little bit of side work over here. The area of a triangle formula is 1/2 base times height. So looking at just this triangle, 1/2, your base and your height would be 14 and 8. Those are the ones that are perpendicular to each other. And 1/2, 14 times 8 gives me 56 square feet. So this number right here is my capital B. It's my area of the base. So now I can substitute that into my volume of a prism formula. My height is the line that connects my two bases. So if my triangle is a base, and then I have my other triangle in here, boop, 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 boop. If I were to make this see-through, here's my other base. This 10 connects my two bases, which would give me 560 cubic feet. All right, looking here, we know this is a cylinder, so I come over to my formula sheet, volume of a cylinder formula, volume equals pi r squared times the height. Pi, my radius here, remember radius is half the diameter. If my diameter is 12, my radius is 6. And height connects my bases, it connects my circles, so it would be 5. Pi times 6 squared times 5 gives me approximately 565 and 49 hundredths cubic meters. I'm looking here, I have a cone. So I'm going to do my volume of a cone formula. Volume equals 1/3 pi r squared h. 1/3 times pi. My radius is given to me, it is 2. And my height is 8. 1/3 times pi times 2 squared, which is 4, times 8 is going to give me approximately 33 and 51 hundredths cubic inches. Remember, my height here is the one that is perpendicular to the base. We have a pyramid, so I'm going to rock my pyramid formula. Volume equals 1/3. We have that capital B again. H. Remember that capital B means area of base. In pyramids, they're typically easier to see which one the base is. So we have our base. It looks like a parallelogram or a rectangle, but given the dimensions, we have a square. So area of a square, we could say side squared, or we could do length times width, since we know all squares are rectangles. 6 times 6, and that gives us 36 square units. I say units because no units are given. So now I could put that number right into my formula. I have 1/3 times 36 times the height. Remember, my height is perpendicular to the base, so that would be 4. Multiply those together, and I have 48 cubic units. All right, last one. Volume of a sphere. So I use my volume of a sphere formula. Volume equals 4/3 pi r cubed. 4/3 pi. My radius is given. It is 6 cubed. I multiply all those together, and I get 904 7/8 cubic meters. So quick recap of volume of all of those solids that are shown. And then high school level, we're going to get into modeling with volume. We're going to get into having to find the dimensions that you need using Pythagorean theorem, using trigonometry, using special right triangle rules, and how you can use density with volume problems as well.